Hey guys, Mr. Bowman here. We're continuing with 1.6 geometry. This time around we're moving up to the merit questions, and our first exam is going to be the ones from the 2017 exam. So we've got question 1. The merit questions will be more geometry based as opposed to trigonometry and Pythagoras' theory based. So let's jump into it. Question 1. The pattern below is made up of two regular hexagons. I suppose that word regular, we like seeing that because that gives us some guidance as to what we're wanting to do. We've also been told that AB is parallel to GH. So what that means, AB over here is parallel to that line there. We could probably make a few other assumptions that GCD is going to be parallel to that. It's also going to be parallel to that as well. So all of those should be parallel. So probably going to be regular polygon stuff, probably going to be some parallel line rules in there as well. We've been asked to calculate the size of angle X, which is J or Cij. So let's jump into it first. And what I'm going to do, this area is really going to be the focus of what we're doing. And the thing that I see is this angle, and this angle, they are all going to be that same regular internal angle of a hexagon. So let's start off by finding that, and I suppose we'll get into the formula. So that there is angle HGJ, which is going to be equal to the usual formula 180 n minus 2 divided by n. I now substitute, so that's going to be 180 times 4 divided by 6, and 720 over 6, and that gets me to 120 degrees. Couple reasons that we need to write down. Internal angles of six-sided shape equal 720 degrees, and that's the numerator of what we're doing, and we're dividing it by n because it's a regular polygon. All the internal angles are going to be the same. So we're going to have internal angles of regular polygon are equal. So that's our first step. So we now know that there is going to be 120 degrees. And what I'm going to do is I'm going to focus on GH and CD. And just due to the properties of a rectangle, which we've got up there, we know that these are going to be parallel to each other. So I'll probably just state that just to be sure. GH is going to be parallel to CD. And my reasoning is really just the properties of a rectangle. Forgive the messy handwriting for this portion. Now that we've got that, what I'm going to do is I'm going to move to finding this angle down here. It's a bit annoying to see, but it's GID. So angle GID, that's actually going to be co-interior to that 120 degrees. So that's going to be 180 minus 120. That there is 60 degrees. And that's because co-interior angles in parallel lines, they are equal to each other. And now that we've got this angle over here, we can see they are vertically opposite, or that angle is vertically opposite to x, so that means x is going to be 60. So x is equal to angle Cij, which is equal to 60 degrees, and that's because vertically opposite angles are equal. So a lot more steps to this question, and it did involve a bit of construction type stuff, and funnily enough we were using an angle not even inside that diagram. Looking at question number 2, and we've got circles are drawn in a half hexagram. So that's what this thing here is, which is a regular 6-pointed star as shown in the pattern below. A, B, C are the centers of the circles. The radius is r, so we've been given that here. So each of these circles are going to have the same radius of r units long. We've then drawn triangle ABD inside that shape there. we've been asked to prove that angle Z is equal to 30 degrees. So just a reminder, prove is similar to the show questions from the achieve section. So that means they've given us the answer. We have to figure out how they got that answer. So this one, I suppose reasonably tricky, but let's just draw a diagram just to help us out. So here's my right angle triangle, and down the bottom was D, and that was a right angle. I had B, and I had A over here as well. What I know about DB, that is the radius of one circle. So I'm going to call that R for radius. And AB, that's two radiuses because it goes into that top circle and then carries on to that second circle as well. So that there is going to be two lots of the radius. We don't really know much about AD over here because it's not really radius. It's just a line or a tangent to that middle circle. And finally, we've been asked to find out Z. Z was that top angle up there. So even though we don't have the radius, we actually have a ratio, and trig's all about ratio. So this is a trig-based question. So that's the hypotenuse over there. There's the opposite. We don't care about the adjacent. So we're using the sine rule. So sine angle equals O over A. Even though R and 2R are not numbers, I'm going to substitute them in anyway. So sine Z is equal to R divided by 2R. And the reason I'm doing that is R divided by 2R, that's an algebraic fraction. I can cancel out the R on the top and the bottom, and that'll help us find the ratio for this particular angle. So sine Z will be equal to 1/2. Z using our inverse sine, -1, 1/2, and you put that into a calculator, you're going to get 30 degrees. And that shows, or that matches the answer they gave us. So we proved it, and that's enough to get our merit mark. Now on to question number 3 from the website. So basically we've got a big shape, which is a right angle triangle. It's made up of several smaller identical right angle triangles. We've been told that AB is 1 unit long, so AB is coming down there, and we've been told BC are 2 units long, and that's going all the way bottom there. I should note from a previous achieved question, you would have got M equals 26.6 degrees with a 1 dp rounding, and that'll help us with this question here. And the actual question's asking, calculate Y, which is the line GD. So I'll start with drawing a rough triangle, and that's a really bad triangle. Let's draw that again. There we go. So there's a triangle. Down here would be corner B, up the top here, corner G, and down the bottom there, corner D. And we know that this here is Y, because GD is what we're trying to find out. I guess our starting point is line BD carries on all the way to C, and this total length here is 2. As the triangle over here is identical to the triangle over here, we know that BD is going to be half of that 2, so it'll be 1 unit long. So BD will be 1 unit long. We also know this angle here, from the previous triangle, angle M is over here, which means that there will also be angle M. And we were told from the previous question that it was 26.6 degrees. So from here, it's actually just the basic trig question. We've got a measurement with an angle, which means we can find out another side. So let's go through. So the right angle's up there. Opposite to that is the hypotenuse. There's the opposite, which we don't care about. And up the top there is the adjacent. So we care about A and H, which is cosine. So cos angle will be equal to A over H. Let's substitute now. Cos 26.6, that's equal to Y over 1, which is equal to Y, which means Y is equal to cos 26. Put that into our calculator, and hopefully you're getting Y equals 0.86. We don't really have units here, so I'm just going to write down units just to be sure, and that there had a 2 dp rounding. Now on to question number 4, and This one here is a bit trickier. Let's run through all the information. We've got PQ is parallel to DE, so that's trying to say all these lines here are parallel to each other. We've also been given a certain amount of dimension, so PE is 8 centimeters, PD is 5, and then DC is 2. We've been asked to calculate the length of line G. So when I first looked at this question, I really struggled because I didn't have any information on angles, which really weirded me out, and I couldn't figure it out. But once I looked at this in a bit more detail, so this angle up the top, if you're thinking of our triangles, so there's a big triangle and then there's a smaller triangle down the middle. That angle in the top, that is in common for both of these. And this angle and this angle, they are corresponding, so they're going to be the exact same. And then so is this one over here. And what that means is all three internal angles are the same, so we're dealing with similar triangles. So we should start off with our similar triangle stuff. So I know that angle number 1, DPE, and that there is in common for both angles. I also know that angle number 2, I suppose, because we're trying to show that we've got identical angles. So angle PDE, sorry, not having a good time with the marker for this question, PDE, that's going to be equal to PCB, and that's because they are corresponding angles. So corresponding angles in parallel lines are equal to each other. And then finally, the third angle down the bottom, angle PED, that's equal to angle PEC. Same reasoning. Therefore, triangle PDE is similar to triangle PCB. So when I looked at the answer schedule, this part here wasn't useful. It wasn't in there, but I thought you can't really do this question without proving you have similar triangles. Now that we've proved similar triangles, we can get into the ratios. And I know that PD is the corresponding side or the equivalent to PC. So I'm going to go PD over PC, and I know that's going to be equal to PE over PB over PB. There we go. Now let's substitute. So PD is 5, PC is 5 plus 2, which is going to be 7, and that's going to be equal to PE, which is 8, divided by 8 plus G. So I don't know what this is. Make sure you don't put in just G here, because PB is the 8 and the G combined. I'll carry on my working up over here. I'm now going to do a bit of a cross-multiplying approach. So 5 times that, and then 8 times 7 is 56. So let's expand that bracket. 40 plus 5G is equal to 56. 5G is equal to 16. So we did minus 40 minus 40. G is equal to 16 over 5, which means G is equal to 3.2. And our units are centimeters, and there's no rounding there, so we don't need to do that. So yeah, I suppose it's a tough question, but we figured out they were similar triangles. We then used the ratios of the sides to find out that G was equal to 3.2. Question 5, and this is probably the easiest merit question I've seen. We've got a whole bunch of information. We've been told about BC and BE. They're the radius to the circle. They're those two there. So that tells you that these little dashes, it's an isosceles triangle. I've been told that GI is a tangent. So GI, that's a tangent to the circle. And I've been given CGE. We've been told that's 38 degrees over there. The next step, calculate size x. So let's jump into that. Question number 5. So the first thing I did was I figured out that BEG, that there is the relationship between the tangent and the radius, so that's always going to be at 90 degrees. So angle BEG, that's equal to 90 degrees. And don't forget your reason. tangent to radius, that's always 90 degrees. So nice easy first step. What we then can do is we know that angle BEC, which is this angle here, and GEC, they sum to 90 degrees because they're sitting within that right angle that we had there. So because we know GCE, we know that's 32 degrees, we can put that in to find out BEC, which is the one sitting up over there. So that there is 32 degrees. So angle BEC, that's going to be 90 degrees minus 32 degrees. And when you put that together, oh gosh, I wrote 32, but that should be 38. That gets us to 52 degrees. And that reasoning was the same as above because we're really relying on that 90-degree relationship from the tangent to the radius to get to that answer. Okay, so we've done that, and I guess the next step is x and that angle, the green dot that we just calculated, they are the base angles of an isosceles triangle, so they are going to be equal to each other. So I know that angle BEC will be equal to angle angle BCE. They are both going to be 52 degrees, and that's what x is. And that's because base angles of iso triangle are always equal to each other. On to question number 6, and this one here was a bit fiddly, so we had the easiest merit question I've seen in question 5. Question 6 was probably the hardest one that I've seen as well. So let's have a look. So we've got two overlapping circles, and you can kind of see that if I carried on the circles, they would look a bit like that. So they overlap each other, where A and B are the centers of those circles, and drawn in a quadrilateral which is symmetrical through HG. And hopefully you can see that the quadrilateral there goes down there and then back up and then there. So just noting this last one here, that bottom side, it is two slightly declining lines, not the bottom of a triangle. So that makes 4 sides in total. We know the distance between A and B is equal to the radius of the circles. So that there would be the radius distance. We've got a whole bunch of other information as well. There's another rhombus. That was told to us there. We've also been told all of these lines separately are tangents. And finally, we've been told that angle GEC, that there is 38 degrees. And yet more information. We know AD. Where's AD? AD is over here. We know that is perpendicular to GC. So that there is the tangent. Radius perpendicular to the tangent. Okay, so we've been asked to calculate the size of angle Y. So this question, a little bit annoying to start off with. Get into this question and understand what's happening. We're just going to draw a line from F to C. And what we can see here is that line there going down to E, that has an arc over here, and it goes up to the circumference, and then it has the same arc going into the middle. So we know it's probably going to be something to do with the cyclic or the circle theorem rules, where the center circle or the angle at the center is twice as big as the angle in the middle. So this here is also split into half, so that there is going to be 1/2 of y, which then lets us figure out all of y. So our starting point is this angle here, that there is going to be y, so we need to figure out what this is over here. And that relies on this isosceles triangle over here, which is a tangent. And we learned that from the previous question. So we know that angle GEB, that there is 90 degrees, and that was because of the tangent rule. Tangent to radius is 90 degrees. From there, we got the angle in the middle, just over there. That was going to be angle BEC, and that was equal to 90 minus the 38, which got us to 52 degrees, and our reasoning really relied on that 90 degrees from above. That gives us angle X, which is, so angle BCE is also equal to 52 degrees. That's where we left off in the last question. Base angles in iso triangle are equal. From there, we can now get to that angle in the middle. So I know that angle CBE, that's going to be equal to 180 degrees minus 2 lots of 52, because they are all sitting within that triangle, and it's an isosceles triangle. So that there gives us 78 degrees, and that's internal angles of triangle equal 180 degrees. Geez, we're getting there. Okay, we're now going to draw back that FC line, and we can figure out angle CFE, so that angle there. So angle CFE, that's going to be equal to 76 divided by 2, which is equal to 38 degrees. And that's because angles at the center are always twice the angles at the circumference. Angles at center are 2 times the angles at the circumference. So we're nearly there. And then the last one was, so as I said, that there was 1/2 of y. So we need to multiply that by 2. So y is equal to angle FDE, which is equal to 1/2 of y times 2, which is equal to y, which is equal to 38 degrees. And the reason that's really because of that line of symmetry that they talked about. There you go, symmetrical through HG. So that means that y can be split into half like that. And I'll just write that down, due to line of symmetry at HG. So a bit of a messy question, continues on from the previous one, but we got there in the end. Thanks so much for watching this video, guys. Hopefully you found all the merit questions from the 2017 exam useful. Keep an eye out for the other merit ones, and the excellence ones should be on their way.